Today we're talking about relations, domain, and range. Remember that a relation is a set of ordered pairs and can be expressed in four different ways. First way is, obviously, ordered pairs. Second way is a table. Third way is a mapping. And the fourth way is a graph. Okay, remember that the domain is the set of all x values in a relation, and the range is the set of the y values in a relation. And remember that a function is a relation in which none of the first coordinates, in other words, none of the x values, because that's the first coordinate, repeat. So x values cannot repeat for it to be a function. Alright, so let's look at example number 1. Represent the relation shown in the coordinate plane as A, a set of ordered pairs, B, a table, and C, a mapping. List the domain and range and determine if it is a function or not. So let's look at this graph. We're going to take this graph and we are going to represent it in the four ways. It's already represented as a graph. We're going to do the other three. So for first part, ordered pairs, we need to take each of these points, make them ordered pairs. So let's count all the way. Let's start from left to right. So -1, -2, -3, -4, -5, +1. So -5, +1 is my first coordinate. Then -1, -2, -3, -1, -2. So -3, -2 is my second coordinate, this one. And then -1, -2, -1, -2, -3, -4, -5. So -2, -5 is my third. This one here is easy. It's the origin. It's 0, 0. Then here we've got 1, 2, 1, 2, so 2, 2. This one up here is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4, 6, 1, 2, 3, 4, 5, -1, -2. So we've got 5, -2. Okay, so we've taken this graph, we've represented it also as coordinates. Now let's take this and represent it as a table, so the third way. So the table just is x and y points in a table. So we've got -5. Oh, that's not -1, it's +1. -5, 1. -3, -2. -2, -5. Remember, these have to go in order. 0, 0. 2, 2. 4, 6. And 5, -2. Alright, so we've taken our coordinates, put them in an x and y table. Now the third way it wants us to, or the fourth way it wants us to represent is a mapping. Remember, the proper way of doing a mapping is to do your x values from least to greatest and your y values from least to greatest. So let's go ahead, and our x values are already in order from least to greatest. 4 and 5. Okay, let's look at our y values. The lowest is -5. Then we've got -2 twice, but we don't need to write it twice. Then 0, then 1, then 2, then 6. Okay, remember for the mapping, it's different from the table. The table, you've got to write them right next to each other, the ordered pairs. You write them right next to each other. For the mapping, we don't have to do that because we draw the arrow to show which one goes to which. So for this first coordinate, -5, 1, we've got to draw the arrow. -5 goes to 1. Then -3 goes to -2. -2 goes to -5. 0 goes with 0. 2 goes with 2. 4 goes with 6. And 5 goes with -2. Okay, so we have just taken this graph and we have represented it in these four different ways. The same relation is represented as 4 different ways, but they all mean the same thing, just in different ways. So now let's take the domain. So just for sake of ease, I'm going to take the domain from the mapping. You can take the domain from anything because they're all the same. But since the domain for the mappings are in order from least to greatest, to me that's the easiest. So that's what I'm going to do. So come over here, get the x values for a domain. They're -5, -3, -2, 0, 2, 4, 5. Similarly with the y, this is also already in order for the range, so I'm just going to take it from the mapping. -5, -2, 0, 1, 2, 6. And if you chose to use the table or the coordinates or the graph to get the domain and range, you would have came up with the same numbers. Okay, is this a function? Well, let's go back and look at our ordered pairs. Let's look at those x values. -5, -3, -2, 0, 2, 4, and 5. None of my x values repeat. Yes, it is a function. Let's check ourselves. Okay, no x's repeat. How can we check ourselves? Well, we've got the graph right here. Let's go ahead and use the vertical line test. If I draw vertical lines, if I were to drag a vertical line across this graph, would that vertical line touch 2 points at any one given time? The answer is no, it wouldn't. So yes, it's a function because no x's repeat and it passes the vertical line test. All right, let's look at example number 2. State the domain and range, then determine if the relation is a function. So domain is x. Let's look at those x values. I'm going to underline them. 1, -2, 1, -4, 2. So from least to greatest, I've got -4, -2, 1 appears twice. I don't need to write it twice. And then 2. For my range, my y values, I've got 9, 5, 6, -3, 8. So from least to greatest, -3. Then I've got 5, 6, 8, 9. All right, is this a function? You should have noticed when you were reading the domain, the x, that you said 1 twice. No, it's not a function. X value of 1 repeats. Can't be a function. Okay, let's look at example number 3. Express the relation shown as ordered pairs. So let's take this mapping, make it ordered pairs. State the domain and range, then determine if it's a function. So for ordered pairs, we've got 2, 12. We've got, 2 also goes with -3. We've got 1, 5. We've got 0, 0. We've got -1, 5. And that's it. Domain, all my x values from least to greatest, this mapping's backwards. -1, 0, 1, 2. Okay, and then for the range, the y values, we've got -3, 0, 5, 12. Is this relation a function? You should have noticed that 2, the x value of 2, has 2 arrows pointing from it. That means 2 is used twice. So no, it's not a function. The x value of 2 repeats.